Hey everyone, I'm Baba Khandeval and I welcome you all to Simplilearn's YouTube channel. In this session, we will talk about binary search trees. We shall begin our session by introducing binary search trees. Then, we will discuss some of the properties of binary search trees. After that, we will try various operations on them like insertion and deletion. Finally, we will sum up what we have learned from this session. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon below so you never miss an update from Simplilearn. So without any further ado, let's get started with introduction to binary search tree. Binary search tree is a set of nodes organized in such a manner that they all have the same binary search tree characteristics. A key and a value is assigned to each node. The requested key is compared to the keys in binary search tree. So during search, if the key is found, then the corresponding value will be retrieved. Next up, properties of binary search tree. First up, the left subtree of a node contains only nodes with keys lesser than the parent node. Next up, the right subtree of a node contains only nodes that are greater than the parent node. The left and the right subtree each must also be a binary search tree. Next, let's discuss what are the operations we can perform on a binary search tree. First up, insertion. Last, deletion. Let's discuss them in detail. First up, insertion. We can insert a node in such a way so that we obey binary search tree rules. That is, the new node should be either less than the parent node if it's on the left subtree, or if it's on the right subtree, it should be greater than the parent node. Let's execute this in the code editor. We will start by creating a class for the binary search tree. So class BST int data and BST pointers left, comma, right. Next, we will define some functions publicly. Public first default constructor and a parameterized constructor. A function to insert the value. And a function to traverse the node. Now let's write default constructor's definition. So BST Now let's write the parameterized constructor's definition. BST int value data is equals to value and left is equals to null and right equals to null. Now let's write the definition for the insert function. So BST insert BST star root comma int value. Now we will check if the tree is empty or not. So if root, then we will insert the first node. So we will return new BST value. Otherwise we will insert the data. So if the value is greater than root data, then we have to insert it in the right subtree. So root right is equals to insert root right comma value. Else the value should be inserted in the left side. So root left is equals to insert root left comma value. And then we will return root. Now let's write the traverse function. So void bst traverse bst star root. If root then we will return otherwise we will first traverse left side, then we will print the root data. And then we will traverse the right side root, right. Now let's write the main block. So we will start with an empty tree. So BST B, comma, star root is equals to null. The root is equals to B dot insert root, comma, 50. B dot insert equals to root, comma, 10. B dot insert gonna be root, comma, 30. B dot insert gonna be root, comma, 50. Sorry, we already used 50, so we will use 60. B dot insert root, comma, let's use 20. Let's try to traverse this. So B dot traverse root. Let's execute this. As you can see, we have successfully created and traversed our first binary search tree. Let's get back to slides. At last, deletion. We will delete a node following the binary search tree rules. That is, the value of the left subtree should be less than the parent node, and the value of the right subtree should be greater than the parent node. Let's try these in the code editor. Let's start by creating a node. This time we will use structure. So struct node int key struct node star left, comma, star right. Now we will create a utility function to create a new binary search tree node. So struct node star new node int item. Struct node star temp equals to struct node star malloc size of struct node. Next, temp will be assigned the key is equals to item. Temp left equals to null and temp right is equals to null. Now let's write a function to traverse the tree. Traverse struct node star root. So if root is equals to null, so traverse root left cout root e traverse root right. Now let's write a utility function to insert the new node with the given key in the binary search tree. So struct node star insert struct node star node comma int key. So if node is equals to null, then we will return new node key. Otherwise, we will recur down the tree. So if key is less than the node key, then we will insert in the left subtree. So node left is equals to insert node left comma key. Else node right should be inserting key. Now let's return the node. Now we have given a non-empty binary search tree, so we have to return the node with the minimum key value found in that tree. So we will start struct node star min value node struct node star node struct node star current is equals to node. So we will loop down to find the leftmost leaf. So while current and parents left is not equals to null, so current should be equals to current to return current. Struct node star delete node struct node star root comma int key if root equals to null, return root. Now, if the key to be deleted is smaller than the root's key, then it lies in the left subtree. So we will check if key less than root key, then root left will be equals to delete node root left key. Comma key. Now, if the key is deleted is greater than the root's key, then it lies in the right subtree. So else, if key is greater than root, root right is equals to delete node root right comma key. Else, if roots dot left equals to null and root dot right is equals to null, then return null. Else if root left equals to null, then struct node star temp is equals to root right and free root. Return temp. Else if roots right is equals to null, then struct node star temp is equals to root free root. Return temp. Now node with the two children get the in-order successor smallest in the right subtree. So struct node star temp is equals to min value node root right. Now we will copy the in-order successor's content to this node. So root is equals to temp. Now we will delete the in-order successor. So root right equals to delete node root right comma temp p. Now we will return root. Now let's write the main block. We will start with an empty tree. Struct node star root is equals to null. Now root is equals to insert root comma 2 root is equals to insert root comma 5 root is equals to insert root comma 3 root is equals to insert root comma 4 root is equals to insert root comma 7 and root equals to insert root comma 6. Let's try to traverse this. So see out traversal of the given tree. Traverse root. Now first we will delete a value. So see out delete 2 now root is equals to delete node root comma 2 now see out traversal after deleting traverse root. Let's execute this. As you can see, we have successfully deleted 2 and traversed the tree again. Let's get back to our slides. At last, let's sum up what we have learned from this session. First up, left side nodes are always lesser than the parent's node, and the right side node are always more than the parent node. Next, it is easier to search and sort elements in a binary search tree. Finally, a binary search tree offers faster insertion and deletion operations. And this was all for today's session. Hope you guys found it informative and helpful. If you like this session, then like, share and subscribe. If you have any question, then you can drop them in the comment section below. Thanks for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.